So welcome everyone to our Re-FREAM session here. We are today a digital part of the Ars Electronica festival with Re-FREAM. Re-FREAM is a program that brings artists and technologists together to research for a better future of fashion. And today in the Ars Electronica, we have virtual contributions. You can find them in our Ars Electronica Re-FREAM garden. This is the first link you see on the slide. I will also post it in the chat so that you can easily click on it later on if you're interested. And if you want to learn more about Re-FREAM, you can go also to our website or follow us on social media. For every questions you have, please just use the chat, write them down. We will have first a presentation of Julia's work and the work of her co-creation team. And afterwards, we have room and time and happy to answer questions here. If you're rewatching this session later on and not joining in live right now, we also have a LinkedIn group. I share the link later with you in the chat. So if you're rewatching it later on, just go to LinkedIn group, connect with the people there and drop your questions there as well. And in case that you are an artist, you can be the next in Re-FREAM if you want to, and you can sign up for the second round of Re-FREAM. The call is still open until the end of September. And meanwhile, you can now listen to one of our 10 artists from the first round. Here with us today is Julia Körner, and she is now presenting the outcomes of her co-creation that she did with Pavel Kula from Profactor, Guillaume Clement from Haratech, and Naomi Campbell from Stratasys. Welcome all of you, and I'm happy to hand over to Julia now.
Hello everyone, and hi Ganit, hi Vlad, hi. I see a couple of familiar people. I also see my mother, that's great. So I'm going to start sharing my screen. Can everyone see my screen?
Yep.
So thank you so much for having me today at Ars Electronica to show and present the final outcomes of the Re-FREAM project. We can also see here next to me the final prototype, which we will be talking about today. And I'm extremely excited that I have the 4 technology partners here today, actually 3 of them, and the 4th one is in his mind with us, I think. he has other duties at the Ars Electronica. So I'm presenting this project, which I created in co-creation and co-research with Stratasys, Profactor, Haratech, and the University of Linz, the Fashion and Technology Department, who were a consultant on it. And the project is called Digital Vogue Between Organic and Synthetic Processes. So to give you a little bit about background about myself, over the last 15 years, I've specialized myself in design for 3D printing in fashion, product design, and architecture. I have a background in architecture and kind of used these processes for developing innovative designs within different disciplines. And I try to kind of bring in those generative design methodologies into a broader context beyond architecture, such as, for example, also the Hollywood film industry or the haute couture in Paris. And within Re-FREAM, I thought my opportunity really was to engage with 4 technology partners and to co-research and co-create something over 9 months, which is something a little bit different from the way of how I usually would work, because my projects usually tend to be quite fast, and this one was a very long process. So it gave us the opportunity to really look at the development of multicolor 3D printing on textile with totally new innovative ways of thinking about the connection of the fabrics themselves, and to develop essentially a workflow which starts from a series of body scans, developing a digital design methodology to adapt the CAD files from the 3D scans to automate the process essentially to the final garment, which is then printed with the polyjet technology from Stratasys directly on a sustainable material. In this case, we chose 100% natural hemp, and to have a kind of new way of thinking about local production, on-demand fabrication, and mass customization. So we had a couple of co-research focuses. But first of all, I would like to give each tech partner the opportunity to introduce themselves and say a few words about our co-creation. So first, Guillaume, take the stage.
Thanks, Julia. So hi, everyone. Just to introduce myself shortly. My name is Guillaume Clément. I'm an R&D research and development engineer at Haratech, a company in Linz in Austria. And this project was very interesting, and the whole Re-FREAM project in itself, because we're completely from the technical side, from plastics engineering side. And we had the opportunity with Julia and other artists to combine our forces together and to explore and to make new things, which was very exciting. With Julia, we have been working a little bit with FDM 3D printing on some auxiliary research, and mostly then with the 3D scanning, and also with laser cutting to help her in her research phase and to research also together.
Great, thank you, Guillaume. Next, Pavel.
Hi, my name is Pavel Kulha. I work as a scientist at Profactor, which is a research company located in Steyr. And together with Julia, we worked on joinery, on 3D printed buttons and high aspect ratio stuff and so on. So yeah, we were quite successful. Also from the adhesion point of view, because the 3D printed structures need certain adhesion to the fabric to hold the garment all together. And it was really quite wonderful experience for me to work with Julia.
Thank you. And next we have Naomi Campbell.
Hi.
Hi.
Hey, Julia.
Would you like to introduce yourself and say a few words about our co-research?
Sure. I'm Naomi Campbell. I'm creative director for Stratasys, responsible for all the creative collaborations with artists, designers, and architects. Together with Julia, we continued the work that we did with Sete jacket, and we're curious to figure out solutions together with Julia that could be relevant for the commercial market, both the physical parameters of the jacket, enhancing strength, and the adhesion, plus understanding, thanks to Julia, how these parts can be joined together and how this can work as a do-it-yourself type of garment that once it is transported or printed in another location, the customer can actually assemble the entire dress or jacket or necklace or assembly from the location that it has been delivered to.
Yeah, that's a great point. Thanks for bringing that up. It has been a really wonderful experience to work with all three of you together, and I'm super excited to share the further development. Thank you, Naomi. Sander, he unfortunately cannot join us today, but he was also involved as a consultant from the University of Linz, the Fashion and Technology department. With him, I had a direct exchange about developing the workflow, the digital workflow, especially with a focus on tools and techniques I haven't yet had the chance to experience fully before. So I'm going to go a little bit deeper into those while actually sharing the project development. So we looked at the female anatomy of the human body and the kind of figuring out the new way from the traditional methods of seams in a Cartesian way to develop those in a more three-dimensional way. So we took the opportunity to develop the garment entirely in 3 dimension, and then develop a technique of taking the 3D body scans and being able to map and adapt the 3-dimensional forms 2 different personalized sizes. So we found a technique so that the garment actually can be resized and automated, and the 2-dimensional output can then be directly sent with the 3D geometry mapped onto it to the 3D printing hub, where it would be then 3D printed. And then because the joinery is already directly 3D printed onto the fabric, there is no need in kind of the garment necessarily being assembled or sewn together. There's absolutely no sewing involved in the entire garment. So we looked into, with my team, Chenming Jiang was involved in this as a consultant. We were looking at the way of how can we visualize those techniques prior to actually adapting the forms only 3-dimensionally in the computer in a 2D way. How can we actually visualize that adaptation in a 3D way, and how can that inform the design process and the development of the sizes and adaptation of the parts? So we looked at a garment which is actually consisting out of 38 pieces. What you can see here on the left is all the parts disconnected, and on the right side all the parts are being connected. And this allows not only for an individual size adaptation, let's say from size 4 to 8 to 10, but actually if you have like an asymmetric body, or if you want to have your jacket larger than your skirt, or you want to change, then you essentially can adapt the 3D file to a different body type, and the whole 3D geometry automatically adapts. And this is the first time that I have co-researched something like this, and developed an entirely new workflow as to the one I previously used in most of my designs. We have also developed technique of, we had a 3 months research into buttons and joinery and zippers and all kinds of sliders, and developed a kind of idea of how to connect those parts. And with Profactor and Stratasys, we looked into the development of generating enigmatic effects with the multicolor 3D printing. And so here you can see the final collection. I called it the Arid Collection, not only because of the kind of pressing environment situation we find ourselves in, where water is a resource which we have to really take care of, but also because in the process itself of the 3D printing, I developed a geometry which doesn't need any water in the process of the printing to eliminate any support material. So actually only that amount of material is being printed, which is needed. Plus I used 100% hemp material, which is a really organic fiber, and it has a reduced amount of water in its production. So the sustainability element was really important for me in the process. So the entire garment, I call it a collection because it actually can be worn in multiple different ways. And Naomi touched on that before. So it has different elements, and those 38 parts can be combined in different ways. So you have a necklace, you have a corset, you have a skirt, we have a handbag, here again a necklace, and then you have obviously also the full piece. So the garment can be worn in a variety of different ways and can be extended with shorter, longer, and it was a beautiful way to think differently about the garment, and I'm really excited to share the final video with you. The ultimate goal of this project eventually was to look into a digital design workflow, which is fully automated, from a 3D body scan to the computational design algorithms to the final 3D printed geometries, which are 3D printed in multicolor directly on the textile. The Arid Collection focused on a world which is between the oceanic and the arid environment. The 3D printing method directly on the fabric allows me to kind of create a different perspective of the kind of colors from different angles. So when the fabric is in motion, the colors shimmer in a variety of different effects, and that adds another dimension to the layer of the 3D printing on the fabric.
We utilize generative and computational design processes to create the final outcomes, which consisted of 19 main parts as well as an additional 19 accessory parts. Altogether, we had 172,000 mesh pieces. We use meshes because they're versatile, lightweight to process, and are the final output for the printer. We mapped about 15,000 colors onto those meshes, which is something that we were only able to do with Stratasys multicolor 3D printing technology.
I came up with this idea because one of the challenges of consumer 3D printed fashion is the practicality and wearability of the garments. I think that 3D printing on fabric holds the future in fashion because there's a layer of textile between the 3D print and the skin. I think what was unique within this process was that I had 4 technology partners, each individually specialized in their own fields, and that added a new way of collaborative co-research to the workflow. Re-FREAM allowed me to reflect on looking beyond the aesthetic approach. It allowed me to look into rethinking the way of how parts are being connected and coming up with an entirely new, innovative way of joining the modular system in an organic way by looking at the female anatomy and the way of how muscles are being structured in the body and kind of taking those lines and seams into the way of how the elements are combined in the garment. I see the future of this project to take this idea of digital Vogue between organic and synthetic processes to another level. Eventually this evolved into the development of the JK3D series, which is about this idea of a cascading method where you don't have just only one 3D printed dress, but eventually you have a garment which is in its essence a whole collection. It can be a jacket, a skirt, a versatility of accessories, rings, necklace, a corset, a handbag, and therefore you can actually make it more customizable and bring it to a mass market. It aids to the future of urban manufacturing in a larger scale.
Our research was focused on adhesion of 3D printed structures on textiles, possibility of printing on both sides of textile, and together with Julia, we developed a process enabling printed snap buttons on textile. I think we contributed with a big puzzle stone to the future of customized and printed fashion.
And today we're working on a local production instead of global. We want to transport as little as possible. And for sure, we want the consumer to be able to complete his own garment by himself. And I think you solved it in a wonderful way with the little buttons and with the joinery snaps. And I think this really represents the thinking of our time.
As a development and design engineer, I appreciated a lot seeing how Julia works with blending both aesthetical and functional surfaces and elements in the same design. So in the end, we end up with a product that is highly aesthetical and with a lot of functionality at the same time, and all blended in for a very optimized and awesome result.
By working together with artists, we find new ways of using our simulation software in a more creative way and really integrating it into the 3D workflow together with parametric design tools.
Thank you, everyone. So this was the presentation, and I think now we have some time for some Q&A.
Exactly. Thank you, Julia, for this great video and this great presentation. I was at the very beginning from your project, I was involved from an organizational side. And for me, it was really, really stunning to see how this project developed from an idea or research focus to that outcome that you just now showed to us. So really congratulations to all of you. You did a great work.
Thank you.
And to our audience, if you have any questions, please just drop them in the chat and we are happy to discuss. And meanwhile, maybe I want to ask you a little bit to also give our audience a little bit more understanding of the project. And so what Julia mentioned at the beginning was this very intense time of co-creation and sitting together with the tech partners and researching and creating and experimenting and trying. So Pavel, I know that you worked with Julia a lot of times on joining methods and you had a really intense co-creation here. Why do you, in general, you as a scientist, why do you think it's enriching to work with artists in general, and what especially was the benefit to work with Julia for you as a scientist in the co-creation?
As I said, for me it was really a wonderful experience. The cooperation with Julia somehow completely changed my view on fashion design, because it was not my field at all. Also during the testing we worked just with relatively small samples of fabrics with printed structures. But when I saw the final video, I was really impressed how well the upscaling from the technology, from the lab demonstrators to the final garment worked. So this is really impressive and nice. So from the benefits, I think that the main benefit of this cooperation I see in connection of creative thinking of artists and somehow analytical thinking of scientists, resulting in something which is unique and new, let's say.
Yeah, and you also had the chance to work physically, like in the lab, in the same way, in the same day, in the same location. But then in times of Corona, of course, this changed totally. And now one would say, okay, Julia's project now, as she explained, it's a completely digital process. Julia, what do you think if you would have done the whole project remotely and completely digitally also in terms of co-creation? Do you think that the same stunning results would have been possible?
I think that what's unique to the nature of how I usually worked in the past was that I already had done many collaborations which were entirely digitally and entirely, I would say, disconnected. So often I work with like people like, even with Stratasys, with Naomi, I had worked before, and it was an entirely digital process where we would, because we would be in different locations, we would kind of work digitally together. So I was used to that method. But what really I think is always an important part, what I always try to do in the work, is that there's a part which is physical. So whatever project I engage with, I usually tend to go and visit the place to see what technology is available, what is there to start with. And so I remember before the project started, I actually spent like 3 days in Austria, just like visiting the different locations. And I also in December went to work closely together with Stratasys in Israel. And I think this really helped me to inform what is the availability of the technologies, what's the expertise of the scientists, and how can I funnel all of these expertise into the computational design to bring the creation out. And I think what was unique in the kind of physical work together was that you can do very quick turnaround in physical samples, and there's a direct exchange between the scientist, the artist, my research assistant. There was like a lot of different components coming together, which I think were really unique to this project. And I remember the many meetings I had with Guillaume and Pavel and with Naomi and Naomi's team, and with Yossi and Boris in Stratasys, and all the other team members. There were actually, it was a huge team at Stratasys we had meetings with, and Kais was with me there as well. We had so many interesting conversations, which I think I could see pushed all of us into a direction of thinking very different about what potential the applications with this technology have. And so I think that experience was only because it was happening physical, I think.
Yeah, totally. But even though sorry.
No, go ahead.
Even though if you didn't have the physical meetings at the second half of your project, it still was an amazing outcome for that. But of course, we all hope for the second round of Re-FREAM, that also for the artist that comes in the next round, that they will have a similar experience that you did with the physical meetings, the visits, and the insights. So
I think definitely at the beginning it was important. I feel like the second half was less so, because we already had done all the co-creation and the research. It was easier for us to implement those. And at the end, I must say, when I worked with Yossi and Boris and Naomi together, I felt I was actually in the same location, because for over a month, I was kind of on a daily routine, like because of the time difference. There was just like nonstop conversations, even over the phone, over WhatsApp. And it was such a direct exchange that it almost felt like they were in the same city as I was. So I feel, and I must say, I'm really impressed by the kind of shipping speed. Like sometimes I would get the prints within 24 hours from Israel here to LA. So that was like a really quick turnaround, and it made it almost feel like I'm in the same place.
So happy to hear that at least that post offices worked out in all locations. Awesome. So let's go a little bit deeper in the project. We have two questions from our audience. The first is if you maybe can describe a little bit deeper how to go from the 3D scan to the next step. Maybe that's a question that Guillaume can answer together with you, Julia.
Yeah, so maybe Guillaume, you can say a little bit more about your awesome 3D technology you have to make the body scan in 30 seconds. And then I can take the second part of the question.
Yeah, very glad. Exactly. At Haratech, we have the chance to have a body scanner that can take a full picture, of a 3D picture of someone, 3D scan of someone with the color within 30 seconds, which makes it very convenient to hold the pose, and that's it. And in the end, you have a 3D avatar that you can manipulate in every possible way. You can modify the measurements, you can measure things, you can create a mannequin to it, so give it different positions from a standard position. So it's really like taking measurements on a body of someone and then using it to make, for example, tailor-made garments. But in that case, you get even more data than this with the colors, and you can make much more with that, and use this as a mannequin to create your own personalized garment. More details on that, I think you can give Julia, because this is a part that you have done with Fashion and Technology Department also.
Yeah. So what I started to use was I worked with the software CLO and developed a technique how I can kind of use the meshes, what I get from the 3D body scan in CLO, to kind of manipulate and work with the avatar in virtual reality. And then I used the kind of combination of working with Rhino, it's an architectural design software, and Grasshopper, which is a plugin for Rhino, and the software CLO, which is more of a fashion software. And so I worked between those three in kind of going back and forth between 3D modeling the designs, mapping it into 2D, mapping it back onto the 3D body in CLO. So it was kind of like a process back and forth. And at the end, we had a kind of seamless workflow where I can do this now quite quickly. And so we were able to then map the garment onto those 3 different bodies, which we had scanned, and kind of showcase that as an example. And my experience was that this actually enables you to do much more customizable method. There's nothing yet existing where there's a software where you just load it all in and it does it for you. So it's still, it's kind of, I used Re-FREAM to really develop that workflow so that it's automated and that I can faster interact with it. So if I, let's say, design something for a film now and they cast a different actress, I can get that body scan and I can automatically adapt it for that specific body. And it doesn't take me anymore, like maybe 2 weeks to do so. It's now much faster.
Mm-hmm. I think what you now mentioned with the design tools and softwares, it also goes a little bit in the second question that reached us here from Iris. She wants to know if there are any other type of softwares or parametric design tools that you use to create these beautiful, colorful patterns. Is there anything you haven't answered yet that you want to add on this question?
So the geometries, we did like a quite broad research with Stratasys on printing a variety of different geometries and finding kind of also the exact colors we wanted to work with. But for those processes, we explored different routes. We worked at the beginning, we researched a lot with the software Houdini, but eventually it wasn't the right thing for us to move forward because there are different constraints in that software which are not exactly the same as like in Grasshopper. So I prefer much more to work with the Grasshopper plugin for the parametric design because you can actually define sizes, scale, you can work much more precise and determine the outcome. And since there was so much work in the finalization of the pieces, like there was so much back and forth between Stratasys and me on refining the digital files so that they are printable, because we started with like, I think 15,000 colors. Then we had, that wasn't possible to kind of execute because of the kind of size of the data essentially and the management. So we had to kind of very quickly make adaptations to the file. We had to, one ambition I had was to make the gradient of the pattern seamlessly continue to the gradient of the buttons so that the buttons are in the same color range as the pattern, and to also make the sizes so that you can snap it better together and open it up. And those are all fine details which you can manipulate really well in Grasshopper, and much better than in any other software I would know.
Mm-hmm. Thank you, Iris. I hope this answered your question. If not, just let us know. If you have any more questions, just type them in. There is one coming from Christopher. How much time did you spend into your submission concept?
That's a great question. So I actually spent, I would say, like 2 weeks on it. I had a colleague of mine, Max Heidbar, he came into the studio and we made a video together, and we prepared the application video. But before that, I spent like a week kind of writing out what I actually wanted to do in Re-FREAM, but on a very vague end. So I didn't put so much detail into it yet because I really wanted to go open into the research. I wanted to get to know all the tech partners, see all the options I have. And so what I really, if I like go back, actually, I think my idea for this started way earlier. I think in 2018 when I started to work with Naomi Campbell on the first 3D printed designs on fabric. like we started with some initial tests on my studio FDM printer, and then we developed with Stratasys together the CT jacket, which was kind of for me a pilot project for the Re-FREAM project, where we explored for the first time the multicolor 3D printing on denim. And it was for the Koerner collection at the Philadelphia Museum of Art. And in that one, I already had many experiences which I wanted to optimize in the Re-FREAM project. So I kind of had the framework already set up, but then I wanted to being pushed even further with Re-FREAM. And so I would say the actual preparation 2 weeks, but the ideas much longer time. So yeah.
If I may add something yeah. As a tech partner, for having been talking with different artists, that it also depends a lot on the level of experience of who is applying, right? Because for example, you're already quite experienced as a designer, and there's another team like the Yokai team, for example. They had their presentation yesterday, and they are still at the university, for example, for art. For them it was very new, so they had much more to discover, to adapt to. So maybe for the first applications, it was much more of a bigger work, or because much more was unknown, and the more you apply, the more you get used to it, and the easier it goes.
True, yeah. That's a good point to add. Like everyone kind of came with different backgrounds into the Re-FREAM. I feel like we were at different stages in our
career. So for the technical part of applying, and also, as you said, for knowing what do you want to develop. Some people have, like you have been thinking about years already on what they want to do, how, why, where they want to go. And some other people say, hey, it'd be cool to do 3D printing on garments, point. And then you have the whole thinking behind it to make, because of course, Re-FREAM is about having still an open mind, but still also a vision to go to a more or less precise way, like to know roughly where to go and still being open-minded. So that's a whole thinking to do in the foreground.
Thank you. And there is another question to the Re-FREAM project in total, which I try to answer. The question is how we all partners in Re-FREAM found each other. And to that I want to tell you that Re-FREAM is funded by the European Union as part of the Horizon 2020 project. And we are also a pillar of the STARTS project family. And within those networks, there were some tech companies or their scientists that came up with some ideas that it would be interesting to work on the fashion sector with technology and innovate here and see how we can keep the potential for technology also for the fashion industry and to make it more sustainable. And so each partner had a huge network of different partners. And so it turned out that we have now 3 hubs, one in Linz, one in Valencia, and one in Berlin, with different technology partners focusing on different areas. Here in Hub Linz, where Julia and the co-creation team was part of, we focus on 3D technology. In our hub in Valencia, we have partners that are focusing on sustainable circles for producing new materials, and in Berlin it's focused on kind of wearables and electronics and textiles and what can be researched here and how it can be made more sustainable from the terms of the fashion industry here. So this is the frame that Re-FREAM is given in. I also would have another question which might be interested for everyone, because Julia, I know from your general work, your vision is to produce customized, sustainable and ready-to-wear garments that also bridge the gap between can only be worn on runway and also to the gap that everyone has it in its closet. So maybe this is a good question for you, Guillaume and Naomi. What do you think needs still to be resolved with the help of technology so that everyone, not only on runway, but everyone could wear sustainable fashion produced with 3D printing and scanning? What do you think? Maybe Naomi, do you want to start?
Guillaume, you can start.
Yeah, thank you. No problem. Yeah. I think it's mostly about upscaling, because Julia's work over the last month and with the co-creation team just proved that it's there, it's possible. So technical term, the proof of concept is there, but it's with a 3D scanner that doesn't cost the same as a mixer, and with software that you have to afford, and then you need to be in Linz to scan, and then in Israel to have the 3D printing, etc. So yeah, it was the discovering work and journey so far, and now that we know that it is possible, and we know at least some tools that can do it, then it's time for Julia to go further, and maybe also for other actors to step in that project, or to try also their own way, to try different technologies, to find, yeah, so different hardware, different software solutions. For example, the scanner maybe will be also available in any cell phone. In a few years, everybody will be able to do a 3D scan of yourself, and that's it, for example. So, I mean, we have, everyone has a role to play in that game of making the projects bigger and more achievable, more reachable for everyone. And also, I guess that we will have access to technologies in 1, 2, 3 years, 5 years that we are not really thinking of now, or dreaming of, but not so seriously thinking of, I would say. 5
years is not too long. So I'm stoked what's gonna happen then. Naomi, what do you think? You're working a lot with 3D printing technologies.
Yeah, I think, so first of all, of course, support what Guillaume said, and I actually want to take the question a bit to a different angle, and also comment on something that wasn't mentioned about Julia's project. You really see the architecture and the architect expression through fashion. Julia in her education is architect, so we have to also recognize that. And her approach offers something that is completely unique and completely new and authentic to the understanding of what is a clothing piece. And you see it's a composition, it's a structure, it's an architecture. The parts compose together a building that covers the body. And this building is a necklace, it's a bag, it's a skirt, it's a corset, it's a gown, everything is coming together. So it's a puzzle piece, it's a Lego piece, and also the joinery that she created allows this game. If in the future, or I mean, we don't need to wait till the future, but if one incorporates local manufacturing printers, you just email your friend the specific part of the dress that you downloaded or that you bought online, and maybe today you can afford the necklace, tomorrow you can afford the corset, and maybe by the end of the year you have bought the whole gown. And the attachment that we create to the wearing or to the experience is much higher. So this in itself is also a sustainable activity. The fact that we love more, or that we compose ourselves part of the clothing, is something that composes a complete new realization and a new attachment and a new understanding of what it is, and also the creativity of the wearer. I will think today how to wear this thing, how do I combine it with other things that I have in the closet, how do I share, how do I exchange, and maybe after I bought it, I can email it to another friend of mine, and she will select her color range, and we'll go with the same outfit together to the cinema or to the concert, wearing twin sets in each our own sizes. So I wanted to add this because this was not a question that anybody offered, and I really thought this is important to add. Then about sustainability, I'm always very cautious. When we talk about sustainability, we have to understand the complete product cycle. So there are a lot of ways to look at it and a lot of ways to evaluate it. When we talk about the future of fashion, I think indeed we're approaching novelties. We're clearly making new engagements in the fashion domain. And we still have very little that we know about what and how far we can take algorithmic quality into the fashion world. And I think this is going to be project number 3 for Julia, to continue to think about this future. Every time we can only answer a few questions, and every time we can only evolve a few steps forward. And I think that COVID proved to us that it's not about being in one geographical place. The creativity happens in our minds, the creativity happens in the way that we engage emotionally together and intellectually together, and in the way that we communicate. I mean, when we are on WhatsApp, even with my neighbor, I would feel the same as if I'm communicating with Julia. So at the same way, who cares where we are located? We can never be all around. We can never be in all countries at the same time. And it's true. So today, unfortunately, we have to ship the things through air freight. But tomorrow, Julia will just design something by talking to us, and we will be able to produce it in the shop nearby or in our home. So,
what about, Naomi, a printer?
Yes, this is the format to ask
studio.
for. Elegant. It's on the way, by the way, tomorrow morning in a box.
24 hours.
24 hours. Yeah. So
no, I think that's a really relevant point. Like, I think that I always like to make the comparison also with like the paper printer. Like, we have all paper printers at home. We use them to print something out. But when we were to go and print a book, or when we want to publish something, we go to a publisher and we use much higher end machines to produce those. And so I think that's a similar case right now with desktop printers. There are desktop printers also like quite cheap actually to buy already, but there are certain limitations which come with different technologies. And so I think that that's one of the reasons also why I think that multiple things come together. It's like, it's the designer, it's the material scientist, it's the engineer, it's the kind of different mindsets which have to come together to funnel this all into like a product. It's much different than if you compare it with like maybe a rather traditional craftsman where everything is done by like one person. It's a collaborative effort with multiple different minds coming together. And I think that's something very unique, which was also quite in the foreground in Re-FREAM.
There's also a democratic quality that we can look at in the future of printing textiles and printing garments, because one can buy the geometry and print it with an ABS-like material on textile. Another one can afford the multi-color, multi-material. Maybe in the future we print it in gold or in other unique expressions. And the geometry speaks for itself. It's true that every technology offers another quality, but it would be interesting also to have sisters to this garment that are for everybody's home printer and for the basic MakerBot printer, and the industrial quality or the more high-end quality that is done on the polyjet technology. So it's also a question, how do we translate the design idea into practice or into the product? And there are different grades that allow us to do it.
Mm-hmm. There is one last question that is interesting for everything that you just now said, and I think everyone who is not Pavel or Naomi or Julia or Guillaume and has not really touched a 3D printed dress every day or often, how fragile is this dress? It looks so flexible, Lana here writes, but can you actually sit on it? Julia, if it's really fragile, don't sit on it, please.
Yeah,
but maybe as the last question here, you could show us.
I also want to answer. Okay.
No, actually it's really durable. Like I can show you here the handbag too, like the design, like it's actually quite nice to touch and it's quite squishy. And obviously the handbag is a little bit more spiky than the piece. But what you can see is that we actually like, if I bring this a little bit closer, so what you can see is that here in the front it's like a bit more spiky, but then in the back it actually gets quite low, and it gets quite flat. So the model was lying down, sitting down, and the function is kind of embedded in the design. So at certain areas, like underneath the arm here, it gets quite flat, and it's quite durable. Like in comparison to some of the other pieces I've designed in the past, it's actually it's really good. And you can see here the hemp. So this is like the organic fabric what we used, and it's, yeah, I think that it's much more wearable than some of the other pieces I designed. If you look back, like, I don't know, 2012 or so, we were like still printing with like rigid materials, and this is also rigid material printed, but it's printed on fabric, and I think it's the fabric layer which kind of makes it more wearable.
Yeah, actually this sounds like it would be really, really comfy to wear it.
Yeah. Verena, I just want to add to that, just for confidence, we have tested all the garments through laundry, through rubbing, through fatigue. We have really done industrial testing. So our application team has proven to us that indeed these 3D prints on textiles are very durable, and that they also answer the fashion standard. So that is very important to add to this note.
Mm-hmm. Thank you. Yeah, and I think it was the last question for us now, since we're shortly running out of time. But I think it's really cool that you have the prototype here, and that we could now really see how it moves, and that you described how it could feel. So at least I can now imagine how it would feel if I would wear it, actually. And maybe one day, Guillaume estimates 5 years, all of us will wear something like this printed at home. We will see. Until that, I really want to say thank you to all of you for doing this awesome project together, and also thank you to our attendees for joining in today and discussing with us. And everyone else who is maybe rewatching this later, you're very happy to drop your questions in our LinkedIn group. I put the link in the chat, and we are happy if you join our Re-FREAM community and follow us on social media, or if you're interested in more details, just drop us a line. Thank you all for this presentation, and I hope you have a nice evening. See you soon.
Thank you so much. Greetings to everyone.
Thank you. Congratulations, Julia.